So we're going to be looking at inequalities with one variable. We know that an inequality is a greater than sign or a less than sign. On a number line, a greater than sign or a less than sign would be open circles when we graph them on a number line. We also know they're less than or equal to, greater than or equal to, which would be a closed dot on the number line. Okay, compound inequalities are when we have keywords like an and inequality, an or inequality. It must be greater than this and less than this, or it can be greater than this, or it can be less than this. And a solution set. We've already looked at that with solving equations. We've been listing solutions in a set notation because we've just had one solution or two solutions or three solutions. With inequalities, we're going to have multiple solutions, so we're going to use set notation. In order to do set notation, you list your lowest number first and then your highest number, and you either put a parenthesis, which would indicate not included, or a bracket, which would indicate included. Not included would be an open circle, included would be a closed circle. So we're not going to confuse an inequality with an absolute value. An inequality we're going to solve just as we've been solving. I'm going to circle the 4, so we're going to subtract 4. We're going to divide by the -2. Don't forget, when I multiply or divide by a negative with an inequality, the inequality sign will flip. So let's pause and put that note in our notes. So what this means is any number that I put in that's less than -1 will give me an answer that's greater than 6. So I need to show that on a number line. So I always put 0 on a number line, and I'm just going to put my answer, my end point on the number line, and I want everything that's less than -1. So a lot of people do it right here on the number line. I want less than number 1, so -1, so -1 is not included, and I'll shade less than, or you can do it above. Just make sure you put the arrow on the end. So we're going to just test one of these numbers. If I plug in -5 to this x right here, 4 minus 2 times -5 would be 4 plus 10, which is 14, which is greater than 6, so this is right. The next one I'm going to distribute first, and I'm going to get 16x minus 8 is greater than or equal to 11x minus 17. I always move the numbers first, so I'm going to subtract the 11x. Sorry, the variables. I'm going to add an 8 to the other side and get it all done at once. 16 minus 11. The 8's cancel. Both x's cancel. And -17 plus 8. Divide by 5. I'm dividing by a positive, so nothing changes. So x is greater than 9/5, greater than or equal to 9/5. Here's 0, here's -1, here's -2. -9/5 is kind of right here, because -10/5 would be 2, so this is -9/5. And I want everything -9/5 greater than or equal to -9/5. So the easiest number to plug in here would be 0. So 8, plug in 0, is greater than plug in 0. So -8 is greater than or equal to -17. Yes. In both of these questions, I was in the set of real numbers. That's why I didn't not include anything. So how would I write this in set notation? So we're going to do the smallest. So on the left side, the smallest number would be -infinity. I keep going forever. -infinity. My largest would be -1. So the first thing I'm going to do is just write down my smallest number and my largest number. Negative infinity, you can never put your hand on, you can never touch it, keeps going, so I'm going to put a parenthesis on that end because you can never include it because it keeps moving. And here it's indicated that I want everything less than -1. I don't want to include it, so I'm also going to put a parenthesis here. On this right example, I'm going to put -9/5 is my smallest and infinity is my largest. But indicated here, I do want -9/5. I want to be greater than or equal to -9/5. But again, I can't put my finger on infinity, so it would be a parenthesis. Okay, here's an absolute value inequality. So the absolute value of 2x minus 1 is less than or equal to 7. And remember, we're going to solve this twice. One for the positive and one for the opposite. Notice how I've written them exactly alike, except I put negative in front of the first. Notice, moving forward, I don't have any absolute value bars. I just have parentheses to distribute this negative. Okay, if we were to work this out, I would get 2x is less than or equal to 8. X is less than or equal to 4. I'm going to distribute this. Or you could divide by a negative. Just remember, if you divide by this negative both sides, this will turn to a -7, but this will flip as well. So -2x plus 1 less than or equal to 7, subtract 1, divide by -2, and my inequality flips, and this becomes -3. Okay, so let's graph this on a number line. I want -3, I want 0, and I want 4. And initially, I want everything that's less than 4, and I want everything that's greater than or equal to 3. Less than or equal to 4, sorry about that. Okay, so obviously this is an AND inequality, okay? But notice I'm on the set of integers. So I only want integers between -3 and 4, so I would have a dot at -3, -2, -1, 0, 1, 2, 3, and 4. So the red part would not be part of my answer anymore because I only want the set of integers. I can't use set notation to indicate what solutions I have because I'm not going from one number to another and including everything in between. I'm just using -3, -2, -1, 0, 1, 2, 3, and 4. So I'm going to put them in set notation. Set notation is used when you have individual answers and not a whole bunch of answers continuous. Okay, another review, a compound inequality. So the first thing I'm going to do is I'm solving for x, so I'm going to distribute the middle. And I'm going to get -4 less than or equal to -x plus 1 less than 4. And how I kind of remember this is I have two inequalities, so everything I do to the x I need to do twice on both sides. So I'm going to subtract 1 here on the right and on the left. You get -5 less than or equal to -x less than 3. I'm going to divide by -1 to make this a positive. Divide by -1 on both sides. Don't forget, dividing by a negative will flip my inequality. And inequalities are always written from the smallest letter to the largest letter. I have the x in the middle, so my x is pointing towards the 3, and the 5 is pointing towards the x. Be careful when you flip it around. I have 0, I have -3, I have +5. I read from the middle, I want x to be greater than -3 and x to be less than or equal to 5. So I want to be greater than -3 and less than or equal to 5. and it would be everything in between. Typically, this is what an and inequality will look like. They will come to meet in the middle, because I want the only solutions that'll work are the solutions between -3 to 5, including 5. If I were to plug 5 in here, I would get a number between -4, could be equal to it, and less than 4. So greater than or equal to -4 and less than 4. If I want to write this in set notation, I put my smallest number, my largest number, -3 is not included, 5 is included. Last example, this is an or inequality. This is a compound inequality using the word or. So what that means is I want values of x that will give me something that's less than 4. X, that value plus 7 will give me something less than 4, and 7 minus that value will give me something less than 1. Let's go ahead and solve these. This is going to give me x, x is less than -3, or I'm going to subtract the 7 and divide by a negative. That will flip this inequality, +6. If I were to graph that, here's 0, here's -3, here's +6. I want everything less than -3, and I want everything greater than 6. Now, let's try this. Remember in the last one, where you have an and inequality, the number has to fit with both. So I would pick a number here and plug it in here, and they would both work, but this is or. So I'm going to pick the number 7. If I plug 7 in here, 7 minus 7 is 0, that is less than 1. If I plug 7 in here, 7 plus 7 is 14. That is not less than 4, but it doesn't have to meet both requirements. It has to meet this requirement or this. 7 does meet this requirement, so I am good. So let's put this into set notation, and we are going to go smallest to largest. I stop right here. And this is not included, so I'm going to use a parenthesis on either end, and I'm going to go smallest to largest, and again, don't include either. And I would be okay with this answer right here. Mathematically, technically, that wasn't correct English, but I want all of these solutions. All of these solutions will meet these requirements. So I really should write, I want the left set union together with the right set.